Isaac Newton, born in England in 1643, was a remarkable man whose influence on science is still felt today. He was not just a physicist and mathematician, but also a keen observer of the world around him, always seeking to understand its mysteries. Newton's insatiable curiosity and sharp intellect led him to make groundbreaking discoveries that revolutionized our understanding of the universe and its laws. His work laid the foundation for modern physics, and his theories continue to inspire and guide scientists in their research today. Newton's contributions to science are vast and wide-ranging, covering various fields and disciplines. He developed the laws of motion, which describe how objects move and interact with each other, forming the basis of classical mechanics. He also invented calculus, a powerful mathematical tool that has become essential in many areas of science and engineering. And, most famously, he discovered the universal law of gravitation, which explains the force that governs the motion of planets and objects. This law not only explains why objects fall to the ground, but also why planets orbit the Sun, providing a unified understanding of celestial and terrestrial mechanics. The story of Newton's discovery of gravity is one of the most famous in the history of science. It has been told and retold through generations, capturing the imagination of many. As the story goes, Newton was sitting under an apple tree when he saw an apple fall to the ground. This seemingly mundane event was about to change the course of scientific thought forever. This simple observation sparked a profound question in his mind. Why did the apple fall straight down? What force was acting upon it? Newton's curiosity didn't stop there. He began to ponder the nature of this force. He wondered why the apple didn't fall sideways or upwards. What was guiding its path? Why did it always fall towards the center of the earth? This question led him to think deeply about the forces of nature. This seemingly ordinary event led Newton to one of the most important scientific discoveries of all time. His insights laid the foundation for classical mechanics and changed our understanding of the universe. Newton's observation of the falling apple led him to hypothesize that there must be an invisible force pulling the apple towards the earth. He called this force gravity. Newton reasoned that this force wasn't limited to apples falling from trees. He realized that gravity must be what keeps the moon in orbit around the earth, and the Earth in orbit around the Sun. Newton's hypothesis was revolutionary. It suggested that the same force governing the motion of celestial bodies also affects objects here on Earth. Section 4. Unraveling the mystery. Newton's experiments. To test his hypothesis, Newton conducted numerous experiments and observations. He studied the motion of pendulums, the swing of which is affected by gravity. He also observed the tides, which are caused by the gravitational pull of the moon and the sun. Through his meticulous observations and calculations, Newton was able to formulate his law of universal gravitation. This law states that every object in the universe attracts every other object with a force that is proportional to their masses and inversely proportional to the square of the distance between them. Section 5. A Universe Explained. The Impact of Gravity. Newton's discovery of gravity was a watershed moment in the history of science, marking a pivotal shift in our understanding of the natural world. It provided a unified explanation for a wide range of phenomena, connecting the dots between seemingly unrelated events. From the falling of an apple, a simple yet profound observation, to the movement of planets, which had puzzled astronomers for centuries. His work revolutionized our understanding of the universe and our place within it, laying the groundwork for modern physics. Newton's law of gravity is still used today to predict the motion of planets, providing a reliable framework for space exploration, stars, and even galaxies, helping us map the cosmos. It is also essential for understanding the behavior of objects here on Earth, influencing countless aspects of daily life, from the design of buildings and bridges, ensuring their stability and safety, to the trajectory of a baseball, demonstrating the universal application of Newton's principles.